Hello, welcome back. In this video, we are going to discuss exercise 7.3 from the chapter Triangles. And if you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. So let us start now. First question is triangle ABC and triangle DBC are two isosceles triangles on the same base BC and vertices A and D are on the same side of BC. If AD is extended to intersect BC at P, show that triangle ABD is congruent to triangle ACD, then triangle ABP is congruent to triangle ACP, AP bisects angle A as well as angle D, and AP is the perpendicular bisector of BC. First, we'll prove that this triangle ABD is congruent to triangle ACD. So for that, first we know that this AB and AC are equal. So we can write AB is equal to AC since this is an isosceles triangle and given that AB is equal to AC. Now we know that AD is equal to AD because this is the common side of these two triangles. So we can write AD is equal to AD. Now again, we know that this BDC is also an isosceles triangle. So, BD is equal to DC. So, we got three sides which are equal. So, this satisfies SSS criteria. So, we can say that triangle ABD is congruent to triangle ACD. So, we have proved the first part. Now, we have to prove that triangle ABP is congruent to triangle ACP. How will we do that? First, we can write that AB is equal to AC. Now, AP is equal to AP, right? And since we have got that this triangle ABD is congruent to triangle ACD, this angle BAD is equal to angle CAD, which means angle BAP is equal to angle CAP. So we can write angle BAP is equal to angle CAP. So we got these two sides which are equal and the angle in between those sides which is equal. So we can say that this satisfies SAS rule. So from this we can say that this triangle ABP is congruent to triangle ACP. So we have proved the second part also. Now we have to prove that this AP bisects angle A as well as angle D. Okay, and since we know that this angle BAP, we have got these two triangles as congruent. So this angle BAP is equal to angle CAP, which means this angle A is divided into two equal parts. And if this is divided into two equal parts, we can say that this AP is the bisector. So this AP is the bisector of angle A. Okay. Now we have to prove that this AP is the bisector of this angle D also. So for that we have to prove that this angle BDP is congruent to angle CDP. How will we prove that? Just we know that this triangle ABP is congruent and this triangle ABD is congruent to these triangles, right? So to its corresponding triangles, right? So, triangle ABP minus triangle ABD will give this triangle BDP and this CDP. So, we can say that these two triangles are also congruent, right? So, these two triangles are also congruent and from that we can say that angle BDP will be equal to angle CDP, which means this AP bisects angle D also. Okay. So from that we can say that AP bisects angle D. So we have proved the third part also. Now we have to prove that this AP is the perpendicular bisector of BC. How will we prove this? That is, we have to prove that this angle is 90 degree. How will we prove this? We have already got that this triangle APB is congruent to this triangle APC, right? So, if these two triangles are congruent, angle APB is equal to angle APC. But BC is a line. So, this angle should be equal to, this full angle should be equal to 180 degree. That is, if this has to be equal, and this full angle is 180 degree means angle APB is equal to angle APC. So we can say angle APB plus angle APB is equal to 180, right? So 2 times angle APB is equal to 180, which means angle APB is equal to 180 by 2, which is equal to 90 degree. So this angle APB is equal to 90 and angle APC is also equal to 90, which means this AP is we have already got that this AP is the bisector, and now we have proved that this is the perpendicular bisector. So this AP is the perpendicular bisector of BC. Okay. Next question is AD is an altitude of an isosceles triangle. This AD is an altitude of isosceles triangle ABC in which AB is equal to AC. Show that AD bisects BC. We have to show that this AD bisects BC. That is, this BC is divided into two equal halves by this AD, and AD bisects angle A. Okay. We are given that AB is equal to AC, and the altitude of a triangle makes angle 90 degree with a base. So this is 90 degree. So angle ADB is equal to angle ADC is equal to 90 degree. Okay. So this side is equal and this angle is equal. And we know that for an isosceles triangle, the angles opposite to equal sides are equal. So this angle and this angle are equal. So angle ABD is equal to angle ACD. So we got two angles and one side which are equal. So this satisfies AAS congruence rule. And from this we can say that triangle ABD is congruent to triangle ACD. Okay, first we have to prove that AD bisects BC. We know that BD and CD are the corresponding parts of congruent triangles ABD and ACD. And from CPCT rule, that is corresponding parts of congruent triangles rule, we know that this BD will be equal to CD because they are corresponding sides of congruent triangles. And now we have to prove that AD bisects angle A. We have already got that these triangles are congruent. So angle BAD and angle CAD are the corresponding angles of congruent triangles, which means angle BAD is equal to angle CAD. And from that we can say that AD bisects angle A because this angle is equal to this angle, means this AD is bisecting angle A. Okay. Next question is two sides AB and BC and median AM of one triangle ABC are respectively equal to PQQR and median PN of triangle PQR. Show that triangle ABM, this triangle, is congruent to triangle PQN, this triangle, and then triangle ABC, this full triangle, is congruent to triangle PQR. So we are given that AB is equal to PQ and AM is equal to PN. Now this BM is equal to, since this is the median, BM is equal to half of BC. So what is BC? BC is equal to 2BM. And since PN is the median, QN is equal to half of QR. So what is QR? QR is equal to 2QN. But QR and BC are equal. So 2BM is equal to 2QN. So 2BM is equal to 2QN, which means BM is equal to QN, right? BM is equal to QN. So we got AB is equal to PQ, then AM is equal to PN, and BM is equal to QN. That is, the corresponding sides of these two triangles are equal, which means triangle ABM is congruent to triangle PQN. Okay, so we got this. This part is we have to prove that this triangle ABC is congruent to triangle PQR. We know that AB is equal to PQ. And we know that this BC is equal to QR. We are given that. And since this triangle is congruent to this triangle, that is triangle ABM is congruent to triangle PQN, angle ABM and angle PQN are the corresponding angles of these two triangles, which means this angle will also be equal. That is, angle ABC will be equal to angle PQR. So we can say that this angle ABC is equal to angle PQR. So we got these two sides and one angle in between the sides which are equal, which means these two triangles are congruent. That is, triangle ABC is congruent to triangle PQR. Okay, understood? Next question is, BE and CF are two equal altitudes of a triangle ABC. BE and CF are equal. Now, using RHS congruence rule, prove that the triangle ABC is isosceles. We have to prove that this triangle ABC is isosceles. So, let us take this triangle, that is triangle BCF and triangle CEB. This triangle CEB. So, we are taking these two triangles and let us prove that these two triangles are congruent. So, we are given that BE is equal to CF and BC is equal to BC, common. So, we got BE is equal to CF and BC equal to BC, two sides which are equal. Now, since this is the altitude, this angle will be 90 degree. That is, angle CFB is equal to, this angle also will be 90 degree. That is, angle CEB is equal to 90 degree. Okay, so we got this BE is equal to CF, then BC is equal to BC. That is, hypotenuse and one side of the triangle is equal to hypotenuse. This hypotenuse and other side of the other triangle. So we can say that these two triangles are congruent. That is, triangle BCF is congruent to triangle BCE. Okay, so triangle BCF is congruent to triangle BCE. Now, since these two triangles are congruent, that is triangle CBF and triangle BCE are congruent, these two angles will be equal. The angle of this triangle, right? And this angle of this triangle. These two angles will be equal, right? So, angle CBF is equal to angle BCE. And we know that if two angles of a triangle are equal, then the sides opposite to these two angles will be equal. That is, AB will be equal to AC, which means two sides and two angles are equal. That means this triangle ABC is an isosceles triangle. So, we have proved that triangle ABC is an isosceles triangle. Okay, understood? Next question is, ABC is an isosceles triangle with AB equal to AC. Draw AP perpendicular to BC to show that angle B is equal to angle C. ABC is an isosceles triangle and we have to draw AP perpendicular to BC to show that this is 90 degree. To show that angle B is equal to angle C. So, here given that ABC is isosceles triangle with AB is equal to AC. So, AB is equal to AC. AP is perpendicular to BC. So, here this angle will be 90 degree and we know that AP is equal to AP, which is common to these two triangles, that is triangle ABP and triangle ACP. Okay, so AP equal to AP. And since this is perpendicular, we know that angle APB is equal to angle. So two sides and one angle. And so since these two triangles are congruent, angle ABP and angle ACP are the corresponding angles of these two congruent triangles, which means angle B is equal to angle C. Okay, understood? So we have finished doing exercise 7.3 and with this I am winding up this video. I will be uploading some more extra questions from this chapter and the upcoming chapters in the upcoming videos. So stay tuned, and if you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. Do not forget to click the bell icon to get notifications also. Thank you and bye.